Good morning. This is for our Thursday's class on April 2nd. We will go over section 3.4 and 3.5 today. But it's okay. 3.4 is pretty short, okay? I only have about 5 examples to go over, which will take me about less than 30 minutes. After watching this short video, I want you to go to Canvas, try the 3.4 problem that I posted on Canvas just now. The one that I picked, I'm going to ask you to practice your quotient rule skill after watching, after grading your 3.3 problem, where I've seen, some of you trying to avoid that quotient rule by writing it as a product, but forgetting to use the product rule. I think we're going to try to practice the quotient rule a little more. But one of the examples that one of the examples that we're gonna go over today in this very note, we don't have to use the quotient rule, but I will use quotient rule. 3.4 homework is also posted. I just opened it. Looks like somebody already kind of opened it. I don't know if you noticed it too, but I've been getting emails from some of you, and then I'm noticing it too. My math lab is not really working in the evening lately. So if you're working on your homework, and if you're running into those issues, just let me know. We can add more dates to your homework, but it'll be great. Because in the morning when I go in the morning, because last night I was trying to edit your 3.4 homework and it wasn't just working. So this morning I was able to fix that real quick. But you will see 3.5 lesson coming up very shortly right after this. But let's get started on our 3.4, okay? We're doing something called optimization. We're really finding the absolute maximum and the absolute minimum of a given function. And 3.5 is all about application, but we're going to mainly in 3.4, we're just going to practice with the given functions. We have these functions. We will find the maximum and minimum. Example 5 is kind of similar to what you will do in section 3.5, but this is going to be the only application problem that we will look at in this very video. Okay, so let's get started. Okay, they want you to find the absolute maximum and absolute minimum values of f of x, and f of x is not a quadratic. It looks like it's a cubic function. So if you want to find absolute maximum and absolute minimum, what you're going to have to do is you're going to have to first find the critical value. So find f prime of x. Okay, find f prime of x. If you take the derivative of this function, you will get 3x squared minus 3, right? Then to find the critical value of this polynomial function, we will set this derivative equal to 0. And then solve for x. So if I add 3 to both sides, I will get 3 equals 3x squared. Divide both sides by 3, I get 1 equals x squared. Now, I will take square root of both sides at this point, but notice when I take even root of both sides, not only that I will get x equals positive 1, I get x equals negative 1. Okay, and now this is what you're gonna do after this point. I'm gonna give you, in this section, you will get an interval. Over the interval, -2 to 3/2. You can have a absolute maximum or absolute minimum on those endpoints too. So what you're gonna have to do is you're gonna check the function value for both of these endpoints. So you're gonna have to do 4 substitutions. First, find f of -2. That's the left endpoint, right? And then find, and it really doesn't have to be in order. You just have to evaluate all your endpoints. So this 3/2 is the second endpoint, the right endpoint. So you need those two. Not only those two, but also remember the 2 critical values that we just found. X equals plus or minus 1, you will need to find those values too. So let's find f of 1 and f of -1. Okay, ready? So after this point, all you really need is your f of x. We're going to plug in these 4 numbers into f of x. So first, this will be -2 cubed minus 3 times negative 2, oopsies, plus 2. Notice I'm plugging these functions into, these values into f of x, okay? I'll just get a calculator and do them all, but just gonna write down the work that I'll be doing on my calculator. I'm just plugging in these values into my f of x. And lastly, negative 1 cubed minus 3 times negative 1 plus 2. All right, let's get these y values. Ready? Okay. I'm typing these into my scientific calculator. You should try them with me too. In case I make a little mistake, it will be great if you let me know. The first one, when I typed it in, I got 0. The next one, I'm going to enter 3 over 2 into x. So you know, this is that tedious part that's going to take a little bit longer in this section, but it's nothing more than evaluating functions. Guys, I got 7 over 8. What I noticed on your My Math Lab homework was that these guys want you to, they're going to ask you to, they'll probably tell you to round this to the nearest hundredth. So I may just round this to 0.88. I got 0.875, but I noticed when I typed in the exact fraction value into your homework problem, they graded it wrong. They wanted you to round it to the nearest hundredth. So if it tells you to do that, you should do that, okay? All right, next one, you do 1 cubed minus 3 times 1 plus 2. That's going to give you 0. Oh, I got 0 up here too. Anyways, let's keep going. The very last one, if you do negative 1 cubed minus 3 times negative 1 plus 2. If you do that, you will get positive 4. Now we are ready to decide which one is the absolute maximum and which one is absolute minimum here, okay? So let me circle some of these. Which one of these y value was the greatest? Notice 4 was the greatest y value, right? So our absolute maximum value is 4. And this happens at x equals negative 1 because that was the greatest y value that we got from plugging in, right? Now let's look at the absolute minimum. Out of these 4, which number was the smallest? Well, it looks like both the 0 and 0, these two numbers are the smallest. This number is the smallest, right? So we're going to tell them that the absolute minimum value is at 0, and this happens at negative 2, and what's the other x value? 1, okay? So, the middle, this guy right here, I mean, it wasn't anything. It was just a critical, well, it was just an endpoint. But that's how you do this. And this is really the same process, just kind of, and I just prepared different looking functions. But if you understand this, I mean, if you know how to take the derivative and find the critical values, I think you're good. But let's keep going. I'm going to go over all the other ones that I prepared for you. All right, this one is going to be very short. Let's see. Find the absolute maximum and absolute minimum of this function. G of x is just a linear function. So let me take the derivative of g. G prime is equal to negative 9. All right. Now, can this be 0? Can negative 9 be 0? No, right? Can it be under... You know what? We have a case. There is no critical value. We got no critical value. So guess what? What we're going to just do is we're just going to check the endpoints, okay? So all you have to do is find g of negative 2 and g of 5 and compare who is bigger. Okay, so sometimes this happens if you don't have any critical values. like any local minimum or local maximum in between these two given endpoints, then we're just gonna have to go with the endpoints. And there's nothing wrong with that. And because if you think about it, isn't this just a linear function starting at 1, 2, 3, 4? No, it's not starting at 9. It's starting at 2. And then it's going down 1, 2, 3, 4, 5, 6, 7, 8, 9 over 1. So what we're looking at is a function that's just going down like crazy. So I know which one will be smaller. G of 5 will be smaller because, the bigger the x is, the smaller the y value will be, since this is a decreasing function. But because you will need to actually give them these values, plug them in. -9 times -2 plus 2. That's going to be 18 plus 2. So g of -2 is positive 20. Let's do this one. -9 times 5 plus 2. That will be -45 plus 2. So I got -43. So which one is the absolute maximum? Absolute maximum is at x equals -2 and the value is 20. Because that's the bigger number. Absolute minimum, the smallest y value that we have is -43. And this is happening at x equals 5. So that one was, I wouldn't say special. It just didn't have any critical values in between -2 and 5. In that case, just go with the endpoints, okay? Now, let's look at some more interesting functions like h of x that I got here for you. I know that I will need to find the critical value, but I noticed that h of x, it will be great if we can rewrite it first, don't you think? Let's rewrite it so that we have x plus 16 times x to the negative first. And then let's take the derivative of this. What is h prime of x? That will be 1 minus 16 x to the negative second power, right? So h prime of x is equal to 1 minus 16 over x squared. Now, this is undefined at x equals 0, right? Well, I think I should talk about that too, yeah. Well, anyways. So we gotta check the critical values. Let's find some critical values. Because not only that you're going to later find, you're going to have to find f of 4. Where did I get that from? That's the first endpoint, right? And also, what else do you need? F of 20, right? But you're gonna also have to go evaluate a couple of these critical values, and you may have more than one. Example 1, we had 2 critical values. Number 2, we didn't have any. But let's go ahead and work with the function that we got right here. So first, I'm going to set it equal to 0 and solve for any critical values that I have. Now look, this will turn into 0 if 16 over x squared is equal to 1, right? Now, okay, if you want to really, okay. Now, this is equal to 0, 1. 16 over x squared is equal to 1 if the denominator is 16. Because the only way to get a 1 is if you divide something by itself, right? So or you can say, hey, I'm going to go ahead and multiply both sides by x squared. And you can get that x squares canceled out. And you will now have, I'm out of room. Let me move it over here. You will have 16 equals x squared, right? Now, you take square root of both sides at this point. But, some of us have to be careful because we always forget about that negative case. X can be either positive 4 or negative 4, right? Now, let's look at one more. Critical values happen when the derivative is equal to 0 or when the derivative doesn't exist, right? Now, take a look. this function h prime of x is not going to be defined when x is equal to 0. Why? Take a look. H prime of x is 1 minus 16 over x squared. Imagine plugging in 0 in here. What will happen? Well, the fraction will be 16 over 0. That's undefined. So we got actually 3 critical values, okay? But we better talk about these 3 critical values, okay? Because look, they gave you an interval, didn't they? What they told you was, hey, I want numbers that are in between positive 4 and positive 20. Look at these 3 numbers that we just found. 0 is smaller than 4. So, well, it's a critical value. It's just not in the interval they wanted. So we're not going to use that. What else? Let me try to just cross it out with like a yellow pen so that people can see that we still try to find it. Now, I got x equals 4 and x equals negative 4, right? But which one is the only one that's actually in the interval? X equals positive 4 is the only one in the... Oh no. You know, guys, because, I mean, it looks like... But I gotta... Let me just play a little bit, okay? I'm gonna go ahead and see if I can minimize this little bit. Oh, how awesome. You know, I think I just write too big, don't you think? All right, is the only one in the given interval. So I'm not going to test f of negative 4 or f of 0. I wrote it down over here and I realized, oh, I got f of 4 written down already. I don't need to do that twice. So we did all that hard work, but it looks like we're only testing 4 and 20. And that's okay. That's perfectly okay, right? So let's test these 2 values. Let's evaluate these 2. F of 4 will be plugging your values into h of it. Well, didn't I just say f? All right, I'm sorry. The function name is h. You know, I keep changing these function names and I keep going back to f. All right, if you plug in 4, you will get 4 plus 16 over 4. That is 4 plus 4, we get 8. Let's plug in 20 into h. 20 plus 16 over 20 is equal to 20 plus 4 over 5. What's that? 100 over 5. Oh, no. Oh, hold on. Is it? Yes. Plus 4 over 5. So I get 104 over 5. And in decimal, what's that going to be? Let me try. Oopsies. You don't see what I'm doing because I am on my calculator right now. 104 divided by 5 is 20.8. So, which one is bigger, guys? Which one is bigger? Because the bigger one, we're going to be calling it absolute maximum. Let me circle the one that's bigger. 20.8 is bigger. So, we'll say absolute maximum value is, well, I'm going to give them the fraction. 104 over 5. And that happens at x equals 20. The absolute minimum is at x equals 4 and the value is 8. All right, so that was a little bit interesting, don't you think? Now what we're going to do is we're going to do one more that is going to be very similar to what you will do for me on the 3.4 problem. All right, in the back, find the absolute in the same direction. Let's go ahead and find the derivative. Notice q of x is a quotient. That's why I called it q of x. It's the quotient. Anyways, let's use the quotient rule. Quotient rule. I'm reminding you that 3.3 problem, just please go with the quotient rule. It's much easier. The numerator cancels out pretty nice. So don't try to use the product rule because you're going to actually, the product rule will actually be a little bit longer on 3.3 problem. And 3.4 problem too, let's practice the quotient rule a little more. You know what that is? F over G prime is equal to, the denominator is going to be G squared. The numerator is gf prime minus fg prime. And my new little thing is that I label my f and g and everything. F is 4x, right? That's my f. F prime is then just 4. G is x squared plus 4. And then g prime is going to be 2x. Now I'm ready to find the derivative g prime of x. Let me, the q prime of x. Let me move the work down here, okay? So if I use the quotient rule, the numerator will be gf prime. So g times f prime minus f times g prime. And all of these are getting divided by g squared. X squared plus 4 is getting squared. Now, I'm going to go ahead and simplify this, okay? Now, hold on, this guy needs to be a little bit smaller over here for me. All right, that equals, I'm distributing 4x squared plus 16. And, well, if I multiply these two, I get minus 8x squared. And these are all over x squared plus 4 squared, right? Let's simplify this. I see there is a like term, 4x squared minus 8x squared. That will give me negative 4x squared plus 16 all over x squared plus 4 squared. Now we got the derivative. This is our q prime, right? This is our q prime of x. Now let's find the critical value. Critical value happens when this function, when this derivative is equal to 0 or when it doesn't exist. So not only that we're going to check for the zeros of the numerator, because zeros of the numerator is when this function equals 0. We also need to find the zeros of the denominator. Because notice, a fraction is undefined when the denominator is equal to 0. So let me go ahead and find my critical values. Critical values. The first equation, take a look. The first equation is when I set this numerator equal to 0 because that's when this q prime of x is going to turn into 0. Now, what's the other case? I also need to set the denominator equal to 0 because when that denominator is equal to 0, my q prime will be undefined, right? So you really need to check or solve both of these. Ready? Let's find some critical values. This one I'll get negative 4x squared equals negative 16. X squared equals positive 4, right? And then if you take square root of both sides, you get x equals either plus or minus 2. Now, let's test something or let's see something. I got two numbers, positive 2 and negative 2. Are these both in the interval given? The interval given is from negative 6 to positive 6, right? And I noticed that my 2 and my negative 2 are both in the interval. So I'm going to have to evaluate f of 2 and f of negative 2, both later. All right, let's find the values that will make our q prime of x undefined. So here, if I'm solving this equation on this part, I will have to square root both sides and get x squared plus 4 equals 0. Subtract 4 from both sides, I get x squared equals negative 4. Now, I'm about to take square root of both sides. Uh-oh, look what happened. We get x equals plus or minus 2i. So we'll just say this one has no real solution. No real answer solution. So, well, unfortunately, we got no critical values when we are testing the denominator. So we got 4 numbers to plug in. You ready? Let's plug in f of -6. Where did I get that from? That's the first endpoint. Also find f of +6. That's my second endpoint right there, right? The right endpoint. Now we also found 2 critical values, 2 and -2. You know, I love my function name f. I keep writing f, but I was trying to be creative and I called this function q, so I better find all these q's. Ready? I'm gonna go ahead and plug these into my calculators, but just if I want to show what I'm doing, I'm plugging in -6 into the original function, okay? So I'm doing that. I'm gonna do 4 times 6 over 6 squared plus 4 over here. Oh, guys, it's just more writing than... I know you're doing this on your calculator already, but I want to write it because sometimes I'm typing things incorrectly if I'm not looking at something. Okay, I am about to go to my scientific calculator and type all these little guys, and you ready? You do the same thing too there for me. Okay, so the first one, if I plug in -6, that will be 4 times -6 on the numerator, 36 plus 4 in the denominator. Guys, I got -3, whoopsies, what are you doing? I probably have clicked something. -3 over 5. And just because it's easier for me to use decimal, I'm also going to write the decimal value because I want to compare these later. That is -0.6. Next one will be I think it's going to be exactly the same except for the sign. Yes, it's going to be 3 over 5, which is positive 0.6. Okay? All right, next one, I'm plugging in 2. I got 1. This one was exactly 1. So I know the bottom one, a q of -2 is going to be just what? -1. And that is true. All right. Now I got 4 y values to compare. Which one is the greatest? The biggest number is when we plugged in 2, we got a value 1. So the absolute maximum value is 1. And this happened at x equals 2. Let's find the absolute, minimum. What is the smallest value that we have here? The smallest value that we have is -1. And this happened at x equals -2. So let's write those down. Okay, absolute minimum value is -1, and that's at x equals -2. Now, this one took us a little bit longer, not because the process of finding absolute maximum and absolute minimum was difficult, but just because the function was a quotient. We were working with the rational function. So taking the derivative using the quotient rule took just a little bit more time, and we had to consider both the value when the derivative was 0 or it was undefined. That's why it took a little bit longer. But I want you to do something like this because I want to see your quotient rule, okay? Let's do the last one, and then that will be it. Example 5, business. An employee's monthly productivity, M, in number of units produced is found to be a function. Oh, how wonderful. Of the number T of years of service. I would think the longer a person works at this company, the more productive this person will be. But take a look at this function. What kind of function is this? This is a quadratic, and this is a type that's opening downward, isn't it? Because the leading coefficient is negative. So this is what they're saying. At first, a person's productivity goes up the more years of work they do. But at some point, it's gonna go down. That's what they're saying. I wonder why. Alrighty, let's go ahead and work with this function. They want you to find the maximum productivity and the year which it is achieved. What are they gonna do after that point? All right. Well, we do know how to do the math though. Let's find the derivative. And we're doing this because we want to find the critical values. And why do we want the critical values? Because that's where the local maximum happens, right? May happen, we should say. All right, what's m prime of t? That's going to be negative 4t plus 120. And this is a linear function, so it's going to be defined everywhere. So I'm just going to set this equal to 0 to find my critical value. So 4t equals 120. I get the critical value is at t equals 30. So one critical value to test, but what I must do is to check if this critical value is in the interval given. This interval, well, look, they gave you a interval notation, but in interval notation, it is, no, I think I said interval notation twice in different accents. This is inequalities notation, but it's the same thing as the 0 to 40. So 30 is in that range, in that interval they gave us. So we're going to find it. Let's find m of 0 first. That's the first endpoint. Let's find m of 40. And then lastly, we will find m of 30. Notice we are not plugging these into the derivative function, okay? So what's m of 0? That's going to be negative 2 times 0 squared plus 120 times 0 plus 100. That's just going to be 100, right? Very nice. I'm going to need more room over there. Let's do m of 40. Negative 2 times 40 squared plus 120 times 40 plus 100. My dog is scratching my furniture right now. Now I'm home with her, and because I got 2 dogs, guys, all they do is sleep, eat, poop, all that. But okay, I'm typing this into my calculator. Negative 2 times 40 squared plus 120 times 40 plus 100. That is 2,500. Wow. So after 40 years, this person's productivity is 2,500. Very good. And you see how this is better than someone with 0 years of experience whose productivity was only 100? All right, let's do the last one. Negative 2 times 30 squared plus 120 times 30 plus 100. Stop! Stop scratching. Stop. I'm sorry. All right. So plug in 30 this time, guys. Oh no, guys, I just realized, and I'm sure you also did realize that something was wrong there. You know what I did on my calculator earlier? I accidentally typed in 140 instead of 120 there. So I need to fix my answer up here. Oh, thank goodness. See, I was distracted with that little puppy. All right, so the M of 40 should be 1,700. So I know you were going to email and let me know that one of my answer was incorrect, because I know you guys are watching my video, right? I think so. I know, Faith, you are, right? Hi, Faith. All right. The next one, if you plug in, you will get 1,900. So I got it. I know who will create the maximum productivity. That's going to be the person who worked for 30 years. Because this person's productivity is 1,900. So we'll give them these answers now. All right, the maximum, A says the maximum productivity is achieved in year 30. Is in year 30. T equals 30, right? And the maximum productivity is 1900 units. I don't know what they are creating, maybe toys, but that's gonna be it. And after year 30, year 31, 32, this person's productivity will go down because we know the shape of this function is a upside down parabola, right? Now that's enough. I think I just maybe was talking a little slow, but I think you got examples 1 through 5. I'm going to go ahead and post this on Canvas for you, but I will ask you to now try this problem, the 3.4 problem that I don't think anybody started just yet. It's on Canvas. It's the one where you have to use the quotient rule. So please try to label your F and G and everything. And